Hello and welcome to Martin Maths. I'm preparing a lesson for my Year 10s on circles. So I've drawn the best circle I can with some sellotape. First thing we need to do is make sure we know all the parts of a circle. So I'm going to label it like if you're doing biology or science, you've got to label the diagram. This on the outside is the circumference, like the perimeter, but for a circle. The line that goes from one side of the circumference to the other through the center is called the diameter, denoted D, which is useful because unlike a lot of maths it's usually got a different symbol. The line that doesn't go through the center but goes from one side to the other is a chord. I'm not sure the relationship with musical chords, but maybe someone can tell me. The line that goes from the center to one side, so half the diameter, is called the radius, helpfully denoted R. And that then leaves us just with two more things. A part of the circumference, say from there to there, is called an arc length. And that part of the circle is called a sector. Okay, so hopefully we'll all remember those different parts because we're going to use them a lot. So let's quickly turn this over and look at some examples. We must remember the area of a circle is pi r squared, so that's the radius squared. Pi being the circumference divided by the diameter, and for our purposes 3.14 we'll use, but your calculator will have a button for that. The circumference is pi times diameter, or twice the radius times pi. Again, 3.14 will work well enough for us. So let's look at some different examples rather than just straightforward circles. We're going to look for one where there's a circle where part of it has been cut out. So we've got 3/4 of a circle. So say 90 degrees has been cut out. So we know we've got 270 degrees here. Out of 360, we've got 3/4. So whatever we work out for the area, we're going to times that by 3/4. Say the radius was 6, we'd have 3/4 pi times 36. That would be 9, we'd have 27 pi. So 27 times 3.14. If it's a calculator paper, we'd use a calculator and work it out to be something like 84 point something, but a non-calculator paper, 27 times pi would be sufficient. If we needed to work out the perimeter of the shape, we'd need 3/4 of that circumference, which is 3/4 times 12 pi. Those would cancel, be 9 pi. So 9 times 3.14, a bit more than 27. Using our calculator, it's actually 28.26. But don't forget that's only that. If we actually wanted to enclose that shape, we'd need to add 12. 6 there and 6 there. So you get 40.26. Okay, a couple of other things just to think about. We might be asked about sector side arc length. So if we have part of a circle with an angle there, theta, we need to know what fraction that is of the whole circle. Remember, whole circle is 360 degrees. So that angle divided by 360 would give us the fraction, and then we'd times that by, well, if we're wanting area, or if we're wanting, as in this example, I did there with 270, would times theta divided by 360 times the circumference. Okay, and then it just depends whether they're asking for arc length or perimeter. If they're wanting perimeter, they want the 2 radii in as well. If they just want arc length, then it's just theta divided by 360 times pi d. Okay, so there we go. That's some circles, area, perimeter, circumference, and the labeling of the circle. To my Year 10s, we'll continue this in class. For everyone else, thanks for watching.